Yo, welcome to part 15. Okay, we're recording. Cool. So I actually started a few minutes ago, but I realized I wasn't recording. So that was sad. Okay, but at least uh I realized it just as I was starting. So it's cool.
6 and
I'm gonna start this video just for the sake of that part that I was able to record.
we've
Yeah,
got
let's
some
go. So, by the way, we're in pre-algebra and ratios and stuff in here. Yeah, so part 14 was this thing. So we're done with that, and then we're gonna go ratios, rates, proportions. Yeah, so this is the first video of it. Let's go.
apples here and we've got some oranges. And what I want to think about is what is the ratio? What is the ratio of
Again. I'm recording. Cool. Alright. Not gonna make the same mistake.
apples
I don't know. I'm always paranoid about this.
of apples to
Ratio of
oranges?
apples to oranges.
To oranges. And to clarify what we're even talking about,
This
a ratio is giving us the relationship between quantities of two different things. So there's a couple of ways that we can specify this. We can literally count the number of apples, 1, 2, 3, 4, 5, 6. So we have 6 apples.
6 to 9, then 6
And we could say the ratio is going to be 6 to 6 2. And then how many oranges do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 6 to 9. Ratio of apples to oranges is 6 to 9. And you could use different notation. You could also write it this way. 6 to, you would still read it as the ratio as being 6 to 9. But we don't have to just satisfy us with this, because one way to think about ratios, especially if we're thinking about apples to oranges, is how many apples do we have for a certain number of oranges? And when you think about it that way, we can actually reduce these numbers, as you might have already thought about. Both 6 and 9 are divisible by 3. So just how like we can reduce fractions, we can also reduce ratios.
Cool.
So if you divide 6 and 9 both by 3, 6 divided by 3 is 2. 6 divided by 3 is 2. And 9 divided by 3 is 3. So we could also say that the ratio of apples to oranges is 2 to 3. Or if we want to use this notation, 2 to 3. 2 to 3. Now, does that make sense? Well, look, we divided each of these groups into 3. So one way to think about it, so if you divide this whole total into 3 groups, so one group, 2 groups, 2 groups, and 3 equal groups, we see that in each of those groups, for every 2 apples, we have 3 oranges. For 2 apples, we have 3 oranges. For 2 apples, we have 3 oranges. So, once again, the ratio of apples to oranges, for every 2 apples, we have 3 oranges. But we could think about things the other way around as well. We could also think about what is the ratio. Of oranges to apples. Oranges
That's gonna be great.
to apples. And here we would essentially switch the numbers. The ratio of oranges to apples. Notice, up here we said apples to oranges, which is 6 to 9, or 2 to 3 if we reduce them. And here we're going to say the ratio of oranges to apples. So we've swapped these two, and so we're going to swap the numbers. Here we have 9 oranges for every 6 apples. So we could say the ratio is going to be 9
For every 9 apples,
to
6. Oranges.
The ratio is 9 to 6. Or if we want to reduce it, for every 3 oranges, so we're going to divide this by 3. So for every 3 oranges, we are going to have 2 apples. So notice, this is just exactly what we had up here. But when we had apples to oranges, it was 6 to 9, 6 apples for every 9 oranges. And now when it's oranges to apples, we say it's 9 to 6. 9 oranges for every 6 apples. Or we could say for every 3 oranges, we have exactly 2 apples.
Well, I'm just gonna check again if our recording is real.
We've got some apples here and we've got some oranges. And what I want to think about is what is the...
It's real. Ratio to ratio review. A ratio compares two different quantities. For example, this is one to the monkeys and bananas. Now there are 4 monkeys and 5 bananas. There are a few different ratio show. There are 4 monkeys for every 5 bananas. The ratio of monkeys to bananas is 4 to 5. The ratio of monkeys to bananas is 4 to 5. Okay, this is the notation. Order matters in ratios. There are a few. 5 bananas. Yes, 5 4. Okay, cool. Same thing. It's reversed. Dana loves rocks. She has 6 pieces of granite, 3 pieces of marble, 14 pieces of sandstone, and 1 piece of slate. What is the ratio of pieces of sandstone into the pieces of marbles? Oh, okay. Oh my god, how many sandstone? 14. Marbles, 3 pieces, 40 to 3, right? Okay, cool. Leon is helping his baby sister Daphne eat her dinner. There are 12 pieces left in Daphne's bowl and 7 pieces squashed in her hair. Ah, it's disgusting. What's your... Oh my gosh, it's disgusting. 12 for every 7. No, it's 7 for every 12. Oh shit. What? Okay. Made a mistake. There are 12 pieces. It's supposed to be like this. What the heck? There are 12 pieces left. Ratio of piece. Ah, in Daphne's bowl. Okay. Okay. It's bowl to her hair. Okay, it's gonna be 12 for every 7. Cool. For the perfect cup of hot cocoa, Eva uses 3 scoops of hot cocoa mix, 10 miniature marshmallows, and 8 ounces of water. What is the ratio of scoops of hot cocoa to miniature marshmallows? 2 to 10. Okay, next video. Basic ratios.
Let's do some example questions dealing with ratios. So we're told the table shows the number of people waiting in line for different rides at an amusement park. So 15 people are waiting in line for the roller coaster, 4 people for the slingshot, 12 people waiting in line for the bumper cars, and 11 people in line for the roundup. What is the ratio of people waiting in line for the roundup to the people waiting in line for the slingshot? Pause this video and see if you can figure it out.
It's 11 to 4.
So we want to know the ratio of the people waiting in line for the roundup. This is the roundup right over here. To the number of people waiting in line for the slingshot. So there's 11 people waiting in line for the roundup, and there are 4 people waiting in line for the slingshot. So the ratio is 11 to 4. Or for every 11 people in line for the roundup, there are 4 people waiting in line for the slingshot. Let's do another example. Katie loves to read. In the last few months, she has read 3 graphic novels, 2 mysteries, 4 science fiction novels, and 21 comic books. What is the ratio of sci-fi novels to comic books? So once again, pause this video and try to work it out on your own.
Wow.
All right, so we want to know the ratio of sci-fi novels. So she has 4 sci-fi novels. The ratio of that to comic books. She has 21 comic books. So the ratio is for every 4 sci-fi novels, she has 21 comic books. Let me do that other color. She has 21 comic books. So the ratio is 4 to 21. The ratio of sci-fi novels to comic books. 4 sci-fi novels for every 21 comic books. Let's do one more example. This is strangely fun. What is the ratio of apples to bananas? Pause this video and try to figure it out. So let's see. There are 1, 2, 3 apples.
To bananas.
So for every 3 apples, how many bananas are there? Well, there's 1, 2, 3, 4 bananas. So the ratio of apples to to bananas is 3 apples for every 4 bananas. Order matters. If they said the ratio of bananas to apples, then this would be 4 to 3. But they say apples to bananas, 3 to 4. 3 apples for every 4 bananas. We're asked to select 3 ratios that are equivalent to 7 to 6. So pause this video and see if you can spot the 3 ratios that are equivalent to 7 to 6. All right, now let's work through this together. And the main thing to realize about equivalent ratios is we just have to multiply or divide the corresponding parts of the ratio by the same amount. So before I even look at these choices, for example, if I have 7 to 6, if I multiply the 7 times 2 to get 14, then I would also multiply the 6 times 2 to get 12. So for example, 14 to 12 is the exact same ratio. Now you might be tempted to pick 12 to 14, but that is not the same ratio. Order matters in a ratio. This could be the ratio of oranges to apples. And we're saying for every 7 oranges, there are 6 apples. You wouldn't be able to say it the other way around. So you would rule this one out, even though it's dealing with some of the right numbers. It's not in the right order. Now let's think about 21 to 18. To go from 7 to 21, we would multiply by 3. And to go from 6 to 18, you would also multiply by 3. So that works. If we multiply both of these numbers by 3, we get 21 to 18. So let me circle that in. That one is for sure equivalent. What about 42 to 36? Well, to go from 7 to 42, we're going to have to multiply by 6. And to go from 6 to 36, we also multiply by 6. So this, once again, is an equivalent ratio. We multiply each of these by 6, and we keep the same order. So that is equivalent right over there. 63 to 54. Let's see, to go from 7 to 63, you multiply by 9. And to go from 6 to 54, you also multiply by 9. So once again, 63 to 54 is an equivalent ratio. And so we've already selected 3, but let's just verify that this doesn't work. So to go from 7 to 84, you would multiply by 12. To go from 6 to 62, what was it? You'd multiply by 10 and 2/6 or 10 and a third. So this one is definitely not an equivalent ratio. Let's do another example.
Someone's knocking. Right, I'm back.
So once again, we are asked to select 3 ratios that are equivalent to 16 to 12. So pause this video and see if you can work through it. All right, let's look at this first one. So 8 to 6. So at first you might say, well, gee, these numbers are smaller than 16 and 12. But remember, to get an equivalent ratio, you can multiply or divide these numbers by the same number. So to get from 16 to 8, you could view that as, well, we just divided by 2. And to go from 12 to 6, you also divide by 2. So this actually is an equivalent ratio. I'll circle that in. What about 32 to 24? Well, to go from 16 to 32, we multiply by 2. To go from 12 to 24, we also multiply by 2. So this is an equivalent ratio. What about 4 to 3? Well, to go from 16 to 4, we would have to divide by 4. And to go from 12 to 3, we are going to divide by 4 as well. So we're dividing by the same thing, each of these numbers. So this is also going to be an equivalent ratio. So we've selected our 3, so we are essentially done. But we might as well see why these don't work. Now let's think about it. To go from 16 to 12, how do we do that? Well, to go from 16 to 12, you could divide by 4 and multiply by 3. So this would be times 3/4. You would get 12. And to go from 12 to 8, you could divide by 3 and multiply by 2. So this you could view as times 2/3. So you'd be multiplying or dividing by different numbers here. So this one is not equivalent. And then 24 to 16. To go from 16 to 24, you would multiply by, let's see, that's 1.5. So this right over here would be, you would multiply by 1.5.
1.5.
And to go from 12 to 16, you would multiply, that is, by 1 1/3. So times 1 1/3. So you're not multiplying by the same amount. So once again, not an equivalent ratio.
Recipe.
So right over here, we have the recipe for super cake, which you want to make for your guests that are coming over for dinner tonight. But this recipe right over here, this is for 32 people. This would serve 32 folks. But you only have 16 guests coming over. So if you only have 16 guests coming over, what should be your ingredients here? Or how much of each of these ingredients should you have? And I encourage you to pause the video and think about it.
4 eggs.
All right. So right now we're going to think about, well, we're going to have a slightly smaller super cake. Smaller
half super cake.
Super cake. And you might have reasoned that, look, if we're going to have half as many guests, then each of the ingredients we should just have half as much. And you would be right. Instead of 8 eggs for our smaller super cake, you could have 4 eggs. Instead of 6 cups of flour in our smaller super cake, you could have 3 cups of flour. Instead of 6 cups of sugar, you could have 3 cups of sugar. I'm just taking half of each of these numbers. Instead of 2 cups of butter, you could have 1.
Okay, cool, I'm back.
1 cup of butter. Instead of 6 teaspoons of baking soda, you could have 3 teaspoons of baking soda. And last but not least, instead of 2 cups of water, you could have 1 cup of water. Now, this will work, and this is actually how you should adjust recipes. But there's something interesting about what's similar about these two recipes. The recipe for the main super cake that feeds 32 people, and the recipe for the smaller super cake. And that's the notion of ratios. The ratios between ingredients, or the ratio of how much of an ingredient you need for a given guest. So, for example, you can see here that for every 8 eggs, you have 6 cups of flour. So let me write this down. So for every 8 eggs, we have 6 cups of flour. We have 6 cups of flour, which can be expressed as a ratio of, the ratio of eggs to flour is 8 to 6, which is once again interpreted as for every 8 eggs, I have 6 cups of flour. If I said for every 6 cups of flour, I have 8 eggs, I would have written 6 to 8. So the order here matters. But here I'm saying the ratio of eggs to flour, of eggs to cups of flour, is 8 to 6. For every 8 eggs, I have 6 cups of flour. Well, what about for the smaller cake? Well, here, for every 4 eggs, we have 3 cups of flour. We have 3 cups of flour. So what would this ratio be? Well, for every 4 eggs, we have 3 cups of flour. So the ratio of eggs to flour is 4 to 3. Now, it turns out that these are the exact same ratio. If you have 8 eggs for every 6 cups of flour, or for every 8 eggs you have 6 cups of flour, that's the same thing as for every 4 eggs you have 3 cups of flour. What you're just doing is taking each of these numbers and you are dividing it by 2. So you could say the ratio in either case, the ratio of eggs to flour, let me write this down, the ratio of eggs to cups of flour, let me write 2 cups of flour, in either case is 4 eggs for every 3 cups of flour. This is going to be true for either recipe. You have the same ratio. If you have 8 eggs here, so for every 4 eggs you have 3 cups of flour, well, that means you're going to have 6 cups of flour. And so this is why ratios are helpful. This recipe has a different number of eggs, a different number of cups of flour, a different number of cups of sugar, but the ratios between the ingredients are the same. And so you will be able to have a cake that tastes the same, that essentially is the same cake, but just is a different size.
Word problems.
What we're going to do in this video is tackle some word problems involving ratios. So here we're told that Yoda Soda is the intergalactic party drink that will have all of your friends saying, good this is. You are throwing a party and you need 5 liters of Yoda Soda for every 12 guests. If you have 36 guests, how many liters of Yoda Soda do you need? So pause this video and try to figure it out on your own. Well, they tell us the ratio of liters of soda to number of guests. So you need 5, it's a 5 liters for every 12 guests is the ratio. But we want to have 36 guests. So if the ratio is 5 liters of soda for every 12 guests, but we're in a situation where we have 36 guests, so this is 3 times as many guests, we're going to need 3 times as many liters of soda. So 3 times 5 is 15. 5 to 12, 5 liters for 12 guests, or for 5 liters for every 12 guests is the same thing as 15 liters for every 36 guests. So to answer that question, how many liters do you need? You need 15 liters. Let's do another one of these.
My back hurts. I don't like it.
Here, we just have a picture of a bunch of fish in a tank. And it says there are 8 big fish for every blank small fish. And then it says there are 4 big fish for every blank small fish. So pause this video again and see if you can work through this.
There are 8.
Alright, so let's just count the big fish first.
10.
So there's 1, 2, 3.
Big fish for every 10
1,
small
2,
fish.
3, 4, 5, 6, 7, 8.
There are
So
4
in this
big
tank there
fish
actually are
for every
8 big
5
fish.
small
And
fish.
so let's see how many small fish there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small fish. So in the tank, for every 8 big fish, which you see in red, there are 10 small fish. But here it says there are 4 big fish for every blank small fish. So what would that be?
5.
Well, one way to think about it is we have half as many fish, or half as many big fish, so we divided it by 2. So we're going to have half as many small fish. So we're going to divide by 2. So for every 4 big fish, there are 5 small fish. And one way to think about it, you could divide the fish evenly into 2 groups right over here. So let's see if we can capture, so if you could have, this is, so if I divide it like that, here I have 1, 2, 3, 4 big fish and 1, 2, 3, 4, 5 small fish. Then in this group I have 1, 2, 3, 4 big fish and 1, 2, 3, 4, 5 small fish. So every 4 big fish, there are 5 small fish. These are equivalent ratios. Let's keep going. So here, we're told an ice cream shop uses the following ingredients to make 1 sundae. So they use 2 scoops of ice cream, 4 spoonfuls of sprinkles, 2 tablespoons of whipped cream. How many sundaes did the shop make if they used 32 spoonfuls of sprinkles? So pause the video and try to think about it.
8.
So there's a couple of ways to think about it. Here it says, let's see, we're talking about sprinkles, so that's what's relevant here. 4 spoonfuls for every 1 sundae. So we could say that so the ratio of spoonfuls to sundaes is 4 to 1. 4 spoonfuls of sprinkles. Let me write it this way. Let me write sprinkles. How many spoonfuls? How many spoonfuls per 1 sundae? But here we're talking about using 32 spoonfuls of sprinkles. So that is 8 times as many. So you're going to be able to create 8 times as many sundaes. So you're going to have 32 spoonfuls of sprinkles for every 8 sundaes. So how many sundaes did the shop make? Well, they made 8. Let's do one last example. At a dog park, there are 10 black dogs, 5 brown dogs, 2 white dogs, and 12 multicolored dogs. For every 1 brown dog, there are 2 blank dogs. Pause the video and figure out what goes in this blank. Alright, so let's see. There's 5 brown dogs for every 10 black dogs, 5 brown dogs for every 2 white dogs, and 5 brown dogs for every 12 multicolored dogs. But here you're saying that for every 1 brown dog, there are 2 blank dogs. So what type of dog is there a ratio? So for every brown dog, there's twice as many of that type of dog. Well, here we see for every 5 brown dogs, there are 10 black dogs. So one way to think about it, the number of black dogs is always going to be twice the number of brown dogs. So for every 1 brown dog, there would be two black dogs. One way to think about it, the ratio between brown dogs and black dogs, and it's kind of counterintuitive. I use the wrong colors here. I should use brown and black. So let me do that. So the ratio of brown to black is 5 brown dogs for every 10 black dogs. Or if you divide both of these numbers by 5, you would get one brown dog for every two black dogs. And that's exactly what this statement is saying.
And you're done. Okay, cool. 2 more videos. 2 more videos.
We're told that Burger Barn makes dipping sauce by mixing 2 spoonfuls of honey with 1/2 spoonful of mustard. Sandwich Town makes dipping sauce by mixing 4 spoonfuls of honey with 1 spoonful of mustard. Which dipping sauce has a stronger mustard flavor? So pause this video and see if you can work through that on your own.
Okay. Burger Barn makes dipping sauce by making 2 spoonfuls of honey, mustard, and 4 spoonfuls of honey. Which dipping sauce has a much stronger mustard flavor? Holy shit! I think they're equal, right? So for every 2 you have a half, and for every 4 you have 1. So that's like if you multiply this for every 4, you're gonna have a 1 as well.
Alright, now let's think about the ratios of honey to mustard at each of these restaurants. So first, let's think about the scenario with Burger Barn. So I'll say BB for short, for Burger Barn. So they have 2 spoonfuls of honey for every 1/2 spoonful of mustard. So the ratio of honey to mustard in terms of spoonfuls is 2 spoonfuls of honey for every 1/2 spoonful of mustard. So this is the ratio of honey to mustard. Let me write this. This is honey, and this right over here is mustard. Now let's look at Sandwich Town. So I'll call that ST. So Sandwich Town makes dipping sauce by having 4 spoonfuls of honey for every 1 spoonful of mustard. So the ratio of honey to mustard is 4 spoonfuls to 1 spoonful. So once again, that is honey, and that is mustard. Now, can we make these equivalent ratios, or can we compare them somehow?
Yeah,
well, let's see. We have 1/2 spoonful of mustard here. We have 1 spoon of mustard here. So what if we multiplied both the mustard and the honey spoonfuls by 2? That still would be an equivalent ratio because we're multiplying by the same amount. So if we multiply by 2 in both situations, you have 4 spoonfuls of honey for every 1 spoonful of mustard. Well, that's the exact same ratio that we have at Sandwich Town. So it actually turns out that they have the same concentration of mustard. They have the same ratio of honey to mustard. 4 spoonfuls of honey for every spoonful of mustard in either situation. Let's do another example. So here we are asked, or we are told, Patrick's favorite shade of purple paint is made with 4 ounces of blue paint. So let me underline that in blue. 4 ounces of blue paint for every 3 ounces of red paint. For every 3 ounces of red paint. So the ratio of blue paint to red paint is 4 ounces of blue, 4 ounces of blue for every 3 ounces of red. So 4 to 3. Which of the following paint mixtures will create the same shade of purple? All right, pause this video and see if you can figure it out on your own.
BD.
So this is 3 ounces of blue paint mixed with 4 ounces of red paint. Well, this is a ratio here of 3 to 4. And even though it's dealing with the same numbers, this is a different ratio. The order matters. This is 4 ounces of blue for every 3 ounces of red. This is saying 3 ounces of blue for every 4 ounces of red. So we could rule this one out. 8 ounces of blue paint mixed with 6 ounces of red paint. So here, this ratio is 8 ounces of blue for every 6 ounces of red. Well, are these equivalent ratios? Well, the difference, or you can go, if you multiply by 2 in either case, you will get to 8 to 6. 4 times 2 is 8. 3 times 2 is 6. So this is indeed an equivalent ratio. So we would select this one. All right, here they say 6 ounces of blue paint mixed with 8 ounces of red paint. So this is, once they've swapped the blues and the red relative to this one. So this is a ratio of 6 to 8. So let me write this down. So this is a ratio 6 ounces of blue paint for every 8 ounces of red paint. So just like we ruled out that first one, this is dealing with the same numbers but in the different order, and the order matters. So we'll rule that out. 20 ounces of blue paint, 20 ounces of blue paint for every 15 ounces of red paint. So are these equivalent? Well, let's think about it.
Yep.
To go from 4 to 20, you could multiply by 5. And to go from 3 to 15, you could multiply by 5. So we can multiply by the same factor to go from 4 to 3 to 20 to 15. So this is indeed an equivalent ratio. 12 ounces of blue paint mixed with 16 ounces of red paint. All right, so this is a ratio here of 12 ounces of blue for every 16 ounces of red.
Oh, still
so let's think about this.
To
To go from 4 to 12, you would multiply by 3. Now, if you multiplied 3 by 3, you would have a 9 here, not a 16. So this is definitely not an equivalent ratio. Another way of thinking about it, you have, in terms of ounces, you have more ounces of blue than you have of red for any of the equivalent ratios. But here you have more ounces of red than blue. So once again, another way of realizing that that is not equivalent. So only B and D are the equivalent mixtures that will provide the same shade of purple. To have that same shade, you need the same ratio of blue to red.
Okay, cool. Solving ratio problems with graph.
In a
plot point to show how many pieces of gum were in the pot. Show how many pieces of gum added to Violet's bubble.
In a recent gum chewing contest, Violet tried to blow the biggest blueberry flavored bubble ever. Every 3 seconds, she added 1 piece of gum to her huge bubble. On the graph below, the x-axis represents time in seconds, so this right over here is our x-axis. And the y-axis represents pieces of gum in Violet's bubble. So this is the y-axis right over here. Plot points to show how many pieces of gum were in Violet's bubble after 3, 6, and 9 seconds. So every 3 seconds she adds 1 piece of gum. So let me throw all my, let me throw all of my, so what we care is about 3 seconds, 6 seconds, and 9 seconds. So every 3 seconds, we know that she adds 1 piece of gum. So after 3 seconds, this is 0 right over here. We're not going to worry about negative time. So after 3 seconds, she would have added 1 piece of gum to her bubble. Now, if 3 more seconds pass by, she would have added 1 more, or now she would have 2 pieces of gum in her bubble. And then if 3 more seconds pass by, now we're at 9 seconds, she would have added 1 more piece of gum, and now we're at 3 total pieces of gum. And notice, the ratio between the pieces of gum and the time that has passed has stayed constant, because she's doing it at a constant rate. 1 to 3 is the same ratio as 2 to 6, which is the same ratio as 3 to 9. So let's check our answer. Very good.
Wow, I like the smiley face. Okay, oh shit, it's a lot. Okay, cool. 7-Eleven. What is the ratio of Aaron's trophies to soccer trophies? 3 soccer, 7, 3, 7. Of turtles to seals. That's 5 to 3. The table shows how many of each type of fruit are in a fruit bowl. Oranges, bananas, 5 to 8. Dean loves rocks. He has 6 pieces of granite. So sandstone, 2 pieces of marble. Sandstone got 14. Marbles of 3, 14, 3, 3. Apples to bananas, 3 to 4. Ducks to geese. 96 tubes of paint, yellow paint, 13 white, 92 blue paint. Red paint to white paint. Red 6, white 13. 6 for every 13. Next, equivalent ratios. Equivalent to 7, 10. It's gonna work. And this one's gonna work. So we're going to turn 7, 9. 9, 1, I guess. 3, 3, 1. And 3, 3, yeah. So we're going to 5, 2. Okay. 3 answers. This one times 7. Yeah, this should work out. 50 times 11. Yeah, cool. Later in it go 3, 12. 1, 4. And also, let's see, I think 3, 6, 18 would work. This is by, no, actually not. This is by 4. 3, 12. If we multiply this by 2, get 24. Multiply this by 4, 48. And 1, 4. Yeah, cool. CSS effects, thank you. Ratio word problems. I hate word problems. There are every 3 penguins. 1, 2, 3, 4, 5, 6. 18 Windows Registry. Cool. It's 4 to 6. 4 to 6 or 2 to 3. Or use the following ingredients to make one s'mores. What the hell is that? Just 20 graham crackers. Oh, you're gonna make 10, baby. Cool. A bike shop. There's 11 red bikes, 3 blue bikes, 4 orange bikes, and 12 silver bikes. For every 1 orange bike, there are 3 silver bikes. We want ratio word problems. Oh god, I hate word problems. According to Greg, perfect cherry pies have a ratio of 240 to 3 pies. How many cherries do I need to make 9 perfect cherry pies? Oh my god, it's gonna multiply by 3. So we have 600, and then 40 times 3, we have 720 pies. Cherries, I mean. Mabel spends 4 hours to edit a 3-minute long video. She edits at a constant rate. How long does Mabel spend to edit 9 longer videos? So it's going to multiply by 3. Yeah, 12. Amara needs 45 meat to feed her 2 pet dragons each day. Each pet dragon, it's the same amount of meat. Oh, so to feed 4 pet dragons each day. 90. Justin's rice bowl recipe uses 100 grams of rice to make 1 rice bowl. Justin has 700 grams of rice. So how many rice bowls? Oh, yo, it's gonna be 7. Equivalent ratios in the real world. Okay, math in real world. For every 3 days pick of vacation, Power packs 4 outfits. Okay. Okay, this would be the same. What else? Oh gosh, 3 of these? 3 to 4, right? So it's like 3/4. Okay, this is by 2. No, this is not correct. This isn't correct either. Oh wait, what? 6 outfits? Oh no, no. For every 3 days of vacation, right? You have 4 outfits. The outfit should be more. Ah, okay, that's wrong. A's wrong. This is a pretty tricky question. Trick question, actually. You checking your reading comprehension and shit. Farah would pack 10 outfits for a 9-day vacation. No. Okay, this would work. Farah would pack 16. That's by 4. Yeah. This is by 7. Okay, cool. Flaming barbecue restaurant makes a dipping sauce with 9 ml of hot sauce for every 6 ounces of barbecue. Flaming BBQ's restaurant makes a dipping sauce with 9 milliliters of hot. ML is supposed to be milliliters of hot sauce. And even though I've been drinking coffee, I feel like sleeping right now. I don't know. Gosh, time is it? I think it's pretty early still. See, it's still like 10:30. Okay, so let's see. Choose 3 answers. Okay, let's do this again. Makes a dipping sauce with 9 ml of hot sauce for every 6 ounces of barbecue. So 9 to 6. So definitely the mLs should be bigger. 9 to 6 times, that's 3. Or 3 by 2. So this one's gonna work. Will it work? Okay, so if we multiply this by 10, no, it should not work actually. We need 3 answers. No, this should work. And let's see. 9. This is 3 times 4, and 2 times 4 is 8. Okay, cool. C is the answer? Seriously? 24 multiplied. Oh man, this isn't even a factor of 3. Multiple of 3, I mean. Makoto likes to eat. I hate word problems. Actually, it's just no, it's not. Makoto likes to eat her trail mix piece by piece. Then piece of nuts. No. Actually, yeah. But what? No. By 2, right? So 2 answers. So this one's multiplied by 8. Actually, no. A and E. Peter's beekeep is a beekeeper who sells jars of honey, and honey comes to the market. Every 10 jars of honey he brings to the market, he brings 3 outcomes. Every 10 jars of honey. 3. So 10, 26, 13, 9. Gosh, I made a mistake. This is multiplied by 7. By 7. This is by 6. Yeah, cool. Julia exercises at the gym. For every 10 minutes she spends running, she spends 5 minutes lifting weights. Oh, okay. For every 10, should be bigger. Run for okay. Run for 10 minutes and lift for 12 minutes. Oh, okay. This multiply by 2 for no. By 3. Wait, what? 5 times 5? Okay. By 5 minutes and you get okay. By 2 you get no. 2 answers right, so no. By 8 no. Okay. This one. A great crane is made with 5 ml of black wax for every 6 ml of 6 wax. 6 ml of white wax. The same shade of gray. 2 should be 12. 3. Okay, so 15 and 18. This by 7, 42. Oh, I think that's gonna work. Thomas needs exactly 6 potatoes to make 12 potato pancakes. Which of the following statements are true? Thomas needs 12 potatoes to make 12 potato pancakes. 18 potatoes to make 36 pancakes. Yeah. Good answers. 24 potatoes. Yo, this is multiplied by 4. It's gonna be 48, man. 48 potato pancakes. For 30, I think this would be correct. Let's see. This multiplied by 5, right? 60 by 5. And then this multiplied by 5 would give the same shit. Cool. Okay, I understand. Wait, we aren't done yet? When Arjun makes hot cocoa, he adds 20 ml of chocolate syrup for every 3 ounces of water. Arjun's brother Eli adds 45 ml of chocolate syrup for every 6 ounces of water. Which hot cocoa is more chocolatey? Oh, that's gonna be Arjun's hot cocoa. Because if you have 40, then you go 6. That's more. Oh, actually, chocolate syrup's being added. So it should be Li. So if you have like both 3, it is 6 ounces of hot water, then it's gonna be 40 chocolate syrup. So Li has more. Kermit's favorite iced tea is made with 15 tea bags and every 2 liters of water. Kermit. Okay, the ratio for 15 we had 2. So for this to become 12 with 6, if I multiply 15 by 6, 390. Okay, this is right. Ari thinks a perfect milkshake has 3 ounces of caramel for every 5 scoops of ice cream. Freeze Zone makes batches of milkshakes with 12 ounces of caramel and 8 scoops of ice cream. What will Ari think of Freeze Zone's milkshakes? Oh wow, okay. 3 ounces of caramel for every 5 scoops, while this guy 6 ounces for every 8 scoops. So it's gonna be like 6 and 10. So 6 ounces of caramel. Yo, my brain is not. It's sleepy. My brain is sleepy today. Okay. It's 3 milkshake. That's 3 ounces of caramel for every 5. Wow, I'm feeling dizzy. What the fuck? Insane. I guess this would have too much caramel, because for every 8 scoops there'll be more. This is every 5, so it's gonna be more caramel. Victor's favorite cookie recipe uses 70 grams of butter for every grams of flour. He made cookies using 2 grams for every 400 grams of flour. Okay, so if you multiply this by 2, you get 500 flour. They have too much butter. Yeah, because if you have like 170 grams for 250, if you double that, you 40 grams or smaller amount of flour, then definitely you're going to have much butter. My back hurts and my brain is so sleepy right now. I think I'm gonna take a break a bit. I'm gonna pause this bit. Return. Alright, I'm back. Holy crap, I fell asleep again. Okay, cool. Let's just continue.
We're told the double number line shows that 5 pounds of avocados cost $9. And so what is going on here with this double number line? This shows how as we increase the number of avocados, how the cost increases. So for example, when we have 0 pounds of avocados, it costs us $0. When we have 5 pounds of avocados, it costs us $9. And so if you look at any point over here, let's say you look right over here, this would be, let's see, this is 1, right? This is 1, 2, 3, 4, 5. If you look at 1, this point on the cost number line would tell you how much 1 pound of avocado would cost. 2 pounds of avocados, how much would that cost? You would look at this second number line right over there. So they ask us, based on the ratio shown in the double number line, what is the cost for 1 pound of avocados? So pause the video and think about it. Remember, 1 pound of avocados on this top number line. We look at the second number line. The cost would be right over here. What is this going to be? Well, we could just set it up as a ratio. The ratio of pounds of avocados to cost is going to be, let me do this in some colors. So
what if we like divide 1.8?
If I have 5 pounds of avocados, it is going to cost me $9. So the ratio of pounds to dollars is 5 to 9. So if I were to have 1 pound of avocado, I have divided by 5 to get 1 pound of avocado. I would have to do the same thing for the cost. So if I divide 9 by 5, this is going to be 9/5 dollars of 9/5 dollars would be the cost of 1 pound. Well, 9/5 isn't always the most natural way to write money. So you could view this 9/5 is equal to 1 4/5, which is equal to 1 8/10, which is equal to 1.8, or you could say this is $1.80. So if you were to go on to this double number line, the cost of 1 pound of avocado, this point right over here would be $1.80. If you said 2 pounds of avocados, well, now you would double it. So this would be $3.60. And you would go on and on and on all the way until you got to $9 here. Let's do another example. So here we are told the double number line shows how many model trains Irene can build in a week. So we can see in 0 weeks she can't build any trains, but in 1 week she can build 9 trains. And they ask us which table represents the rate of Irene building model trains. So pause this video and see if you can figure it out.
It's A.
So once again, every week she can build 9 trains. So one way to think about it is the ratio of weeks to trains would be 1 to 9. So let's see. If I look at this table, I just want to see where the ratio between weeks to trains stays at 1 to 9. So 5 to 45, that is still 1 to 9. To go from 1 to 5, I've multiplied by 5. And then to go to 9 to 45, I've also multiplied by 5. So this one checks out. Now, and another way to think about it is 45 is 9 times 5. So 9 times. And that might be an easier way to think about it. Over here, 12 to 108. That's once again, 12 times 9 is 108. And then 26 to 234. Let's see, 26 times 10 would be 260 minus 26. Yeah, it would be 234. So this is 9 times. So in all of these cases, the ratio of trains or the ratio of weeks to trains is 1 to 9. So this one is looking good. So I'll just circle that in. But let's just make sure that this one doesn't work. Well, over here, the ratio of weeks to trains is 9 to 1, not 1 to 9. The train should be 9 times the weeks, while here the weeks is 9 times the train. So just looking at that first one, we know that this is not going to work out. Let's do one last example. The double number line shows how many snowballs Jacob and his friends can make in 1 minute. In no minutes, they can make 0 snowballs. In 1 minute, they can make 12. Complete the table to show the same information as the double number line. So once again, pause this video and see if you can work this out.
1, 4.
Well, we can think about it as a ratio. The ratio of minutes to snowballs is 1 to 12. So minutes to snowballs is 1 to 12. Or another way to think about it is the snowballs is going to be 12 times the minutes.
Wait, did I just zoom my video? Am I recording? Yeah, I am. Not even an R in.
And so over here, if I have 12 snowballs, well, we already know that's going to be 1 minute. If I have 48 snowballs, well, let's just think about it. To go from 12 to 48, you have to multiply by 4. So you have 4 times as many snowballs. It's going to take you 4 times as many minutes. And then if you go to 5, well, to go from 1 to 5, you multiply by 5. So you're going to have 5 times as many snowballs than you would be able to make in 1 minute. So 5 times 12 is 60. And we're done. It could be 1 to 12, 4 to 48, 5 to 60. For every 5 minutes, you can make 60 snowballs. Or they make 60 snowballs.
A ratio table gives a bunch of equivalent ratios. Let's say an example of a ratio table. Ben drinks 1 glass of milk every 2 cookies that he eats. We can use this ratio to begin a ratio table. If Ben drinks 2 glasses of milk, then he eats 4 cookies. Notice that both of the ratio in the ratio table are equivalent. If Ben drinks 4 glasses of milk, then he eats 8 cookies. It is. Wow. Martha needs 28 strawberries for every 4 smoothies she makes. Come to the table using equivalent ratios. For every 4 smoothies she makes. Okay, so this is by 7, so it's going to be 21. And then 10. Luigi uses 39 cups of flour for every 6 pizzas he makes. $39 flours, 6 times 6 is 36. Wow, what is this ratio? What if like divide 39? I'm gonna write some shit down. $6.5. Wow, okay, 6.5. So 6.5 times 4, let's see. 20, 24, 20, 26, 26, and wow, oh my gosh, it's supposed to be 2. Would this be correct? No, actually not. Yeah, it does look like it. Wow, okay. 6. Wow, cool. It really is 6.5 per 1. Okay, so if we divide this by 3, we get 39 to 613. We don't need to deal with decimals. Sticks of butter, number of cookies. 324, that's by 8, so this is 2, and then 45. Wow, okay, it's actually 40. Number of licks. 32.5 licks for every lollipop she eats. Completely see how many licks it would take to eat 6 and 12 lollipops. What? Yo, what? Okay. Yo, it's gonna be double, like, it's gonna be 65. And then 65, 97 and 1/2. Oh my god, wow, okay. This is 62, then 64 plus 1 plus 1, it's gonna be 65, right? Plus another 30. 65 plus another 30, and you get 90. And the 2. Then the half. Yo, what? Oh shit, this is actually 12. Oh my god. I think I'm getting dizzy again. That medicine that I've been taking.
We're told
my allergy.
This table shows equivalent ratios to 24 to 40. Fill in the missing values. And they write the ratio 24 to 40 right over here. 24, when the numerator is 24, the denominator is 40. So in that way you can think of 24 over 40. But then they want us to write equivalent ratios where we have to fill in different blanks over here in the denominator and here in the numerator. And there's a bunch of ways that we could actually tackle this, but maybe the easiest is to start with the ratio that they gave us, where they gave us both the numerator and the denominator, and then move from there. So for example, if we look at this one right over here, the numerator is 12. It is half of the 24. So the denominator is also going to be half of the denominator here. It's going to be half of 40. So we could stick a 20 right over there. And then we could go up here. If you compare the 3 to the 12, to go from 12 to 3, you have to divide by 4. So in the numerator, you're dividing by 4. So in the denominator, you also want to divide by 4. So 20 divided by 4 is 5. And then we have one more to fill in, this numerator right over here. And we see from the denominator, we doubled the denominator. We went from 40 to 80. So we would double the numerator as well. And so you would get 48. And what we just did here is we wrote 4 equivalent ratios. The ratio 3 to 5, or 3 over 5, is the same thing as 12 to 20, is the same thing as 24 to 40, is the same thing as 48 to 80. Let's make sure we got the right answer. Let's do a couple more of these. The following table shows equivalent fractions to 27/75. So then they wrote all of the different equivalent fractions. This table shows ratios equivalent to 18/55. Fair enough. All right, so these are all equivalent to 27/75. These are all equivalent to 18/55. So all of these. Which fraction is greater, 27/75 or 18/55? So this is an interesting thing. What we want to do, because you look at these two things and you're like, well, I don't know, their denominators are different. How do I compare them? And the best way that I can think of comparing them is look at a point where you're getting an equivalent fraction, and either the numerators are going to be the same or the denominators are going to be the same. So let's see if there's any situation here. So you have the situation 54. Where we see 27/75 is 54 over 150. And over here we see that 18/55 is 54, and this 54 jumped out at me because it's the same numerator, over 165. And that makes the comparison much easier. What is smaller, 54 over 150 or 54 over 165?
54 over 165.
Well, if you have the
smaller,
same
right?
numerator, having a larger denominator will make the number smaller. So 54 over 165 is smaller than 54 over 150, which tells us that 18 over 55 is smaller than 27 over 75. So let's see which of these. So this is saying that 27 over 75 is greater than 18/55, and that is absolutely right. Let's do one more of these. Lunara's friends are running a race. Each of them runs at a constant speed, starting at time 0. Which of these tables might show the distances one of Lunara's friends traveled over time? So they're running a race. Each of them runs at a constant speed starting at time 0. So table 1. So distance run in meters. So they're running at a constant speed. So the ratio between distance and time should be constant throughout all of these possible tables. So here you have a ratio of 3 to 2. If you triple the distance, we're tripling the time. If you multiply the distance by 5, we're multiplying the time by 5. So table 1 seems completely reasonable. Let's keep going. Table 2, 11 to 4, and then 12 to 5. Here it's just incrementing by 1, but the ratios are not the same. 11 to 4 is not the same thing as 12 to 5. So we're not going to be able to, this is not a legitimate, this right over here is not a legitimate table. Table 3. So 1 to 1, then when you double the distance, we double the time. When you triple the distance, from 1, you didn't triple the time. So table 3 doesn't seem to make sense either. Table 4, so 14 to 10. So that's the same thing as, that's the same ratio as if we were divided by 2 as 7 to 5 ratio. If we divide both of these by 3, this is also a 7 to 5 ratio. And if you divide both of these by 7, this is also a 7 to 5 ratio. So table 4 seems like a completely reasonable scenario.
I'm out of my mind.
Check our answer, and it is.
I'm definitely gonna fail this. No, not really. Just kidding.
We're told Kenzie makes quilts with some blue squares and some green squares. The ratio of blue squares to green squares is shown in the diagram. The table shows the number of blue squares and the number of green squares that Kenzie will make on 2 of her quilts. All right, this is the table they're talking about. Based on the ratio, complete the missing values in the table. So why don't you pause this video and see if you can figure it out. Well, first let's think about the ratio of blue to green squares. So for every 3 blue squares, that same or similar color, for every 3 blue squares, we are going to have 1, 2, 3, 4, 5 green squares. So the ratio of blue to green is 3 to 5. And so in quilt A, she has 21 blue squares. So she has 21 blue squares. How many green squares would she have? Well, to go from 3 to 21, you have to multiply by 7. And so you would take 5 and then multiply that by 7. So you'd multiply 5 times 7 to get to 35. As long as you multiply both of these by the same number or divide them by the same number, you're going to get an equivalent
so I guess
ratio.
B is going to be
So
like
21
12.
to 35 is the same thing as 3 to 5. Now we have a situation in Quilt B. They've given us the number of green squares, so that's 20. Well, how do we get 20 from 5? Well, we would multiply by 4. So if you multiply the number of green squares by 4, then you would do the same thing for the number of blue squares. 3 times 4 is going to be equal to 12. 12 blue squares for every 20 green squares is the same ratio as 3 blue squares for every 5 green squares. Let's do another example. Here we are told the following diagram describes the number of cups of blue and red paint in a mixture. What is the ratio of blue paint to red paint in the mixture? So try to work it out. All right, so let's just see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cups of blue paint for every 1, 2, 3, 4, 5, 6 cups of red paint. So this would be a legitimate ratio, a ratio of 10 cups of blue paint for every 6 cups of red paint. But this isn't in, I guess you could say, lowest terms or most simplified terms, because we can actually divide both of these numbers by 2. So if you divide 10 by 2, you get 5. We'll do a blue color. And if you divide 6 by 2, you get 3. So one way to think about it is for every 5 blue squares, you have 3 red squares in this diagram, in this tape diagram that's sometimes called. Or you could say for every 5 cups of blue paint, you have 3 cups of red paint in our mixture. And you could even see that here. So 3 cups of red paint and 1, 2, 3, 4, 5. And 5 cups of blue paint. And you see that again right over here. Let's do another example. Here we're told Luna and Ginny each cast magic spells. The ratio of spells Luna casts to spells Ginny casts is represented in this tape diagram. All right. Based on the ratio, what is the number of spells Ginny casts when Luna casts 20 spells? Pause this video, see if you can work it out. All right, so let's just see the ratio here. For every 1, 2, 3, 4 spells that Luna casts, Ginny casts 1, 2, 3, 4, 5
for
spells.
Ginny.
So the ratio is 4 to 5. But if Luna casts 20 spells,
my back hurts.
so
I hate
if
it.
Luna casts 20 spells, well, to go from 4 to 20, we had to multiply by 5. And so we would do the same thing with the number of spells Ginny casts. You'd multiply that by 5, so it's 25. So 4 Luna spells for every 5 Ginny spells is the same thing as 20 Luna spells for every 25 Ginny spells. And so how many spells does Ginny cast when Luna casts 20 spells?
25.
She casts 25. And we're done.
We're done. Equal. Oh, wow. Give this already. One, 2, 3, 4 donor packages. For each donor package contains 3 food vouchers and 5 raffle tickets. Okay, so 3 to 5 is the ratio, right? So choose one answer. So 3, 5, 6, 10, 9, 15. Okay, seems reasonable. Seems doesn't make sense. 5 divided by 7. What the hell? The double number line shows that 3 back to school packages contain 6 expenses. So 1 would be like 12. 1, 12, 2, and 4. Okay. 1 serving beef jerky contains 2 grams of fat and 11 grams of protein. To show the amount of fat and protein, 1 to 3, 4. So 1 would be like 5.5, right? But it doesn't show that. In 1, 2, 3, 4 servings of beef jerky. 1 serving of beef jerky contains 2. Okay, so if you have like 2 beef jerky, fat 14. Oh, okay. The donut that makes 4 apple pies takes 14 pounds of apple pies. Oh wow, that's insane. I think this makes much more sense. Ratios of double numbers. My gosh, the medicine that I've been taking is making me really sleepy. David and Julian are playing a board game together. So they are full cards for David's ore cards. The number double line shows that David will trade 3 ore cards with Julian. For David's ore cards. How many wool cards does Julian needs to trade for 4 ore cards? Crap, my back for real hurts. It's not 7. So it's 3 to 6. And then we have, I guess, 1 to 3. 3 to 6, and then 6 to 9. No, that's not how it works though. Times 3. No, it's not. It's actually just 2. Times 3, right? Times 3. And times 4. So multiply by 4, so you get like 8. 3 minutes. They can sort 150 recycle items in 3 minutes. How many recycle can they sort in 4 minutes? Okay, so that's 3 to 150. We simplify this, we get like 1 over, oh my god, how do we divide this by 3? Oh, it's actually 50. See, I'm really sleepy right now. I hate it. Oh my gosh. 4 bottles of water cost $12. How much does 3 bottles of water cost? Okay, so it's 2.5 per one. 2.5, 7.5. Please be correct. I'm really bored right now. Dog. I'm not burned out. It's just the medicine. So we have 1 times will Pogo fetch the frisbee in 4 minutes. Oh, Pogo the dog. Okay, cool. In 3 minutes. In 3 minutes, it's gonna make 9. Right. Okay, so times 2, we have 6 times 3. Oh, in 4 minutes. Oh god, in 4 minutes. Oh. My brain is so fucking sleeping right now. How long is John? For 2 shirts. So, okay, so 1 shirt would be 14. So if you multiply that by 5, 20, 10, 120. Seconds, please. I'm so bored right now. I'm not really in the mood. 14 for 1 shirt. Wait, what? 20, right? 70. Dude, my brain is so stupid right now. Well, I've already done this video, I guess. The number of lines shows that Tony can type 150 words and 8 words in 2 minutes. In 3 minutes. So if you divide that by 2, you have like 90 and you get to 70 words in 2 minutes. In 5 seconds. So if you divide it by 3, 63 divided by 3, Yo, what is that? I don't know. This is divisible by 3 though. It's actually 21. Oh my god. 21 times 5. I'm so bored. I'm not really bored, I'm just my eyes. In 3 seconds. Time 4 seconds. 36 minutes. Okay, so this is, if we divide this by 4, I would get 9. So we get 27, I guess. Okay. 5 almonds divided by 4. This thing. No, we can't even divide this by 4. So let's see. Uh, 8, 32. Mirren's cooking double. Needs 12 hours to cook 5 kilograms of meat. 3 kilograms of meat. Okay. 12, 5, 2, 10, 2, 20, 2.4 hours per meat. So 2.4, 23 times. So you get 12, 3, 6, 7.2 hours. Avocados. Yeah, that feels so good. I want to finish this though. On a field trip. Okay, so for 8 adults, multiplied by 6, you see the 48. Whoa, 66 children? Oh, okay, so 6, so it's gonna be 11 adults. Wait, what? 6 is 6, it's times 11, so 8 times... Wait, what? No. Yeah, I guess it's gonna be like 11. 15. 6 times 15. I guess it's 90. Double number shows that baker used to spend a kilogram of butter in one day. Which understands a very cheap butter. Okay. 1. Okay, it's 20. 7 40. Okay, this makes sense. Just one answer. This one also makes sense. Oh, 3x 25. Okay, so 75 for 25 150 300. No, I don't know. She said 1 pound of chocolate was $4. Which chocolate was chocolate per pound? Times 4, 28 times 4, 60 times 4 equal. Ratio tables. Fred the clown can create 20 animal balloons every 15 minutes. Complete the table using equivalent ratios. Okay. 20 balloons every 15 minutes. So how much is this per minute? Oh, this is a ratio of 3 to 4. Yeah. Same shit. Not actual 3. That's 0.75. For that's 1.3 degree. Okay, let's see. What is the amount again? 0.75, right? So, oh my god, I made it. So let's try this first. And it's multiplied by 3. This is 60, I guess. And then this one's from 15 to 6. How much is that? Let's just go like divide this. The ratio is 3 to 4. Oh my god, how do I solve this shit? I mean, if we have this, the 7.5, we get 10. Let's say like this is 8. 3 by 4. Oh yeah, of course, and since 6 by 8. Cool. Why am I such an idiot? Oh my god, why? It's really because of the medicine. I blame the medicine. For every dish Andalusia makes. Okay, 4, let's see, it's 13 per chandelier. Multiply that by 4, you get 12. 452 chandeliers for that one. Okay, 13, 130 chandeliers for that one. Han is recovering hundreds of treasure chests from an ancient shipwreck. She is able to recover 8 chests, there are 4 hours. Wow, it's a lot of chests. Okay, so the ratio for this one natively is going to be 2 to 1. So it's going to be 12 and then 5, please. Cool. Gary needs 24 screws for every 2 chairs built. Okay, so one's going to be 12. It's going to be the native of it, 1 over 12. So 6, 72, right? By 9, I don't know, so 108, I believe. Cool. Ratios with tape diagrams. Let's see. Okay, so 3 to 1. Okay, 2 pepperoni pizzas. That's this 5 to 7. 35. 50. Oh my god. Okay. But you know how many pumpkins should Lenny buy when he buys 24 biscuits? 24. It's gonna buy 6. 3 times 6, 18. Okay. Missing that. Okay. We have this 5 to 6, right? Okay. 5 to 6. 12. Around 15. Let's try again. Like ratios. 1. This is 6 to 1. 6 to. This is by 12. 12 feet. 4 to 1. Blue blocks. 4. to 8. 5 to 3. Red notebooks 3. Holy shit. Let's multiply by 8. 8? 3 8s, yeah. 8. So if you have like 540. Okay, what's this? Ratio again? Okay. 4 to 3, so it's 20. Yeah. And kernels 28. Yo, how much is that? Like 7. Excuse me. No, I should do up to the first quiz or the second quiz. I think I can. Yeah, I can. Just a second.
Let him bake. I'm bake. Ah man, I keep on sleeping. But this time around, the medicine I've been taking, it's over. I can finally focus. Oh yeah, I like it. I haven't been first quiz or anything. What the fuck? Okay, cool. Whatever.
We are told that a baker uses 8 cups of flour to make 1 batch of muffins for his bakery. Complete the table for the given ratio. So they're saying that for every batch he needs 8 cups of flour, or he needs 8 cups of flour for every batch. So if he had 2 batches, how many cups of flour would that be? Pause the video and try to figure it out.
16 batches.
Well, if he has twice as many batches, he's going to have twice the number
cups.
of cups of flour. So instead of 8, it would be 16 cups of flour. And if he had 3 times the number of batches, it would be 3 times the number of cups of flour. So instead of 8, it would be 8 times 3, or 24. Now down here, they say plot the ordered pairs x comma y from the table on the following graph. So we want to graph 1 batch 8 cups, 2 batches 16 cups, 3 batches 24 cups. So let's do that. Let's see if we can. Okay, so right here, this I'm assuming on the horizontal axis that is our batches, and then on our vertical axis is cups of flour. So for every batch we need 8 cups of flour. So 1 batch, this is 8 right over here, 5, 6, 7, 8. And then for 2 batches, we're going to need 16 cups of flour. So that puts us right.
Gosh, my back hurts so much.
And then for 3 batches, we are going to need 24 cups of flour. And that actually goes slightly off of our screen here. Let me scroll up a little bit. So for 3 batches, we are going to have to bring that to 24, which is right here. And I can see the 25 right above that. And what you'll see, because the ratio between our batches and our cups of flour are constant, that all of these points, you could connect them all with one straight line because we have a fixed ratio. Every time we move 1 to the right, we're going to move 8 up. Every time we add another batch, we're going to have 8 more cups of flour. Every time we add a batch, 8 more cups of flour. Let's do another example. Here we're told Drew earns money washing cars for his neighbors on the weekends. Drew charges a set rate for each car he washes. The points on the following coordinate plane show how much Drew charges for 2, 5, and 8 cars. So let's see what's going on over here. So when he washes 2 cars, he looks like he charges $15. When he washes 5 cars, it looks like he's charging, well, it looks like someplace between $35 and $40. And when he charges 8 cars, it looks like he's charging $60. So one way to think about it is the ratio between the number of cars he's washing and the dollars, it stays at 2 to 15. Notice, 2 cars for every $15. Or I guess I could say $15 for every 2 cars. And so when you go to 8 cars, you're multiplying by 4 the number of cars, and you're also multiplying by 4 the number of dollars. And so once again, since we have a fixed ratio here, all 3 of these points sit on the same line. But then they ask us, down here, they say, how much does Drew charge for 4 cars? Well, if it's $15 for 2 cars, well then 4 cars would be twice as much. So it would be $30 for 4 cars. We have the same ratio. Let's do one more example. Here we're told McKenna earns money each time she shovels snow for her neighbors, as she should. McKenna plots points on the coordinate plane below to show how much she earns for different numbers of times she shovels snow. All right, so let's see. When she shovels snow 3 times, looks like she gets, see, halfway between 16 and 20, looks like she gets $18. 4 times, looks like it's $24. So it looks like the ratio is staying constant at 3 to 18. The ratio of 3 to 18 is the same thing as, or one way to think about it is $18 for every 3 times she shovels snow. That'd be equivalent to $6 for every time she shovels snow. So let's go down here to see what they're asking us. They say, which of the following ordered pairs could McKenna add to the graph? So this would be 1 time shoveling snow, which she gets $10 for it. So does she get $10 for every time she shovels snow? No, that wouldn't be consistent with the data here. She got $18 for shoveling snow 3 times. So that looks like she's getting $6 for every time she shovels snow. So I would rule out choice A. Choice B, shoveling snow twice, she gets $12. Well, that makes sense. If she gets $6 every time she shovels snow, if the ratio of shoveling of the times to the dollars is 3 to 18 or 1 to 6, that would be equivalent to 2 to 12. And we would pick that choice.
Right.
We're told to complete the ratio table to convert the units of measure from hours to weeks or weeks to hours. So we see here, they've told us already that there's 168 hours for every 1 week. One way to think about it is the ratio of hours for every week is 168 to 1. And then they calculate, well, if we have 1,176 hours, how many weeks is that going to be? So pause this video and see if you can figure it out. Well, let's see, to go from 168 to 1,176, what do we have to multiply by? So let's see, that looks like we might be multiplying by 7. Let me try that out. So 168 times 7.
This is the bit of art they're trying to say.
8 times 7 is 56. 6 times 7 is 42, plus 5 is 47. And then 1 times 7 plus 4 is indeed 1176. So we multiplied by 7. We multiplied the number of hours by 7. So that means we're going to have 7 times as many weeks. So 1 times 7 is just, that is 7 weeks. Now what about a situation where we have 3 weeks? How many hours is that going to be? Well, we are multiplying our weeks by 3. So we would want to multiply our hours. We would want to multiply our hours times 3. So 168 times 3. 8 times 3 is 24. 6 times 3 is 18, plus 2 is 20. And then 1 times 3 is 3, plus 2 is 5. So that would be 504 hours. Let's do another example. So here they tell us the double number lines show the ratio of yards to miles. So the ratio of yards to miles, it looks like we have 3,520 yards for every 2 miles. And you see that on this double number line right over here. Then they say how many yards are in 5 miles. So why don't you pause this video and try to figure it out. Well, the way my brain wants to do it is, well, let's just think about how many yards are in each mile. So if the ratio is 3,520 to 2, well, how could I rewrite this ratio so it is how many yards for every 1 mile? So to go from 2 to 1, I am dividing by 2. So I would want to divide this by 2 as well. So 2 goes into 3,520. Let's see. 2 goes into 3 one time. 1 times 2 is 2. You subtract. You bring down the 5. 2 goes into 15 7 times. 7 times 2 is 14. Subtract. We have 1. Bring down that 2. 2 goes into 12 6 times. 6 times 2 is 12. And we subtract, no remainder. But then we're going to have one more 0 here because we bring down that 0. We say 2 goes into 0 0 times 2 is 0, and we have no remainder. And so this is 1,760. So we could put that here on our double number lines. So if we have 1 mile, that is 1,760 yards. Now they're asking about 5 miles. So 3, 4, 5. So we have 5 miles. What is the number of yards? Well, if you multiply by 5 here, you're also going to multiply by 5 right over there. So what's 1,760 times 5? Let's just figure it out. 1,760 times 5. 5 times 0 is 0. 5 times 6 is 30. Regroup that 3 because it's really 300s. 5 times 7 is 35 plus 3 is 38. 5 times 1 is 5 plus 3 is 8. So there you go, 8,800 yards. 800 yards. Let's do a few more examples. Here we're told there are 914.4 millimeters in a yard. There are 3 feet in a yard. How many...
God damn it, I accidentally pressed the stop recording button and make it work.
Put 3 feet in a yard. How many millimeters are in a foot? Okay, so one way to think about it, you could say there's 914.4 millimeters per yard, or you could say 914.4 millimeters per 3 feet, since 3 feet and a yard is the same thing. So if you want to know per foot, you would just divide both of these by 3. So let's do that. And I'll just do it in a different color here. 3 goes into 914.4. 3 goes into 9 3 times. 3 times 3 is 9. Subtract, we get a 0. Bring down the 1. 3 goes into 1 0 times. 0 times 3 is 0. Subtract, you get a 1. Bring down that 4. 3 goes into 14 4 times. We're going to have this decimal right over here. 4 times 3 is 12. You subtract, and then so you get a 2. Bring down this 4, you get a 24. And lucky for us, 3 goes perfectly into 24. 8 times. 8 times 3 is 24. 24. You subtract, and we have no remainder. So we have 304.8 millimeters for every foot. Let's do one last example. Yuki bought a pound of confetti for $12. What is the price in dollars per ounce of confetti? There are 16 ounces in 1 pound. So pause this video and see if you can figure it out. So let's just write this out in words. So it's $12 per pound of confetti. So you could view this as $12 per 16 ounces. 16 ounces of confetti. And so if we want it per ounce, so you could view this as a 12 to 16 ratio, but we want to say something to 1 ratio. So if you say per 1 ounce, well, we're dividing by 16 there, so we would want to divide by 16 as well. So this is going to be 12 divided by 1.
Per ounce of confetti.
By 16.
Oh.
So 12 divided by, well, let me write it over here. So 12 divided by 16 is the same thing as 3/4. Just divide both of them by 4. And so this is 0.75 or 75 cents. 75 cents per ounce, or 75 hundredths of a dollar per ounce. So 0.75. And we're done. In a language class, the girl to boy ratio is 5 to 8. So for every 5 girls, we have 8 boys. If there are a total of 65 students, how many girls are there? So this is interesting. They give us the ratio of girls to boys, but then they want us to think about how many girls there are given that there are 65 total students. So what we really want to think about is not just the ratio of girls to boys. We want to think about the ratio of girls to total students. Total students. So how can we figure out what this ratio is going to be? Well, the girl to boy ratio gives us a good clue. the ratio for if there's 5 girls for every 8 boys, how many total students are there going to be for every 5 girls? Well, for every 5 girls, you're going to have 5 girls and 8 boys. You're going to have 13 total students. So I just added the 5 and the 8 right over here. The ratio of girls to total students is 5 to 13. One way of thinking about it is if you were to evenly divide the students into groups of 13, every group of 13 students would have 5 girls. Well, the girl to boy ratio gives us a good clue. The ratio for if there's 5 girls for every 8 boys, how many total students are there going to be for every 5 girls? Well, for every 5 girls, you're going to have 5 girls and 8 boys. You're going to have 13 total students. So I just added the 5 and the 8 right over here. The ratio of girls to total students is 5 to 13. One way of thinking about it is if you were to evenly divide the students into groups of 13, every group of 13 students would have 5 girls. Now, I think we're ready to figure out how many total girls there are, because they tell us that there are 65 students. There are 65 students. So we don't just have one group of 13, we have 65 students. And how many groups of 13 is 65? Well, to go from 13 to 65, you have to multiply by 5. 5 times 10 is 50, 5 times 3 is 15, right, 13 times 5 is 65. So essentially, one way you could view it is you have 5 groups of 13. So if you have 5 groups of 13, each of those are going to have 5 girls. Multiply by 5, you're going to have 25 girls. So for every 65 students, you're going to have 25 girls, given the information that has been given. Let's think about another scenario involving ratios. In this case, let's think about the ratio of the number of apples. To, instead of taking the ratio of the number of apples to the number of oranges, let's take the number of apples to the number of fruit. The number of fruit that we have over here. And I encourage you to pause the video and think about that on your own. Well, how many total apples do we have? We have 2, 4, 6, 8 apples. So we're going to have
the very first
8 apples. And then how much total fruit do we have? Well, we have 8 apples, and we have 3, 6, 9, 12 oranges. So our total fruit is 8 plus 12. We have 20 pieces of fruit. So this ratio is going to be 8 to 20. Or if we want to write this in a more reduced form, we can divide both of these by 4. 4 is their greatest common divisor. And so this is the same thing as a ratio. 8 divided by 4 is 2. And 20 divided by 4 is 5. So 2 to 5. Now does this make sense? Well, if we divide everything into groups of 4, or if we divide into 4 groups, I should say. So 1 group, 2 groups, 3 groups, and 4 groups. And that's the largest number of groups that we can divide these into so that we don't have to cut up the apples or the oranges. We see that in each group, for every 2 apples, we have 1, 2, 3, 4, 5 pieces of fruit. For every 2 apples, we have 5 pieces of fruit. And this is actually a good opportunity for us to introduce another way of representing ratios, and that's using fraction notation. So we could also represent this ratio as 2 over 5, as the fraction 2 over 5. Whenever we put it in the fraction, it's very important to recognize what this represents. This is telling us the fraction of fruit that are apples. So we could say 2/5 of the fruit of the number of fruit, I guess I could say, of number of fruit is equal to the number of apples, right? Let me just say 2/5 of fruit, if we're just speaking in more typical terms. 2/5 of fruit are apples. Are apples. So once again, this is introducing another way of representing ratios. We could say that the ratio of apples to fruit once again, it could be 2 to 5 like that. It could be 2, instead of putting this little colon there, we could literally write out the word 2 to 5. Or we could say it's 2/5, the fraction 2/5, which would all sometimes be read as 2 to 5. This is also, when it's written this way, you could also read that as a ratio depending on the context. In a sentence like this, I would read this as 2/5 of the fruit are apples.
Jane earns money walking dogs on the weekends. Jane charges $5 for each dog she walks. X dogs Y dollars. 3.15, 5.5. The film says a maximum number of swimmers that can be in the pool based on the number of blood parts on the game. So when there are two, not like this. Holy shit, what's this? This seems pretty linear, so I feel like 3 and 100, right? So this one's 70, 40. Wow, it's by 35. Okay. Yeah. So that's 70. 5 swimmers here. Whoa, what? Okay. Oh shit, I'd say 95. 105. Ah, crap. I'm an idiot. Break is fine to make a batch of homemade Play-Doh for a month. Okay. So for every 5, you have like 2.5. So half of it, okay. So I have 6, I have 3, and I have 4. So your salt is half. So 1 C would be the answer. Now let's see, 15, 1, 2 cancels with 13, 5. Yo, what the fuck? Contours 15. Oh my god. I'm not paying attention. Okay. So if it charges 15, then it's going to be 30 for 4 cars. I still have 2, 3, so 2, 6, so 1, 3, right? I thought it would work. It's more like this one's, I guess it would be 5, so it's 15. Yeah, okay. So it's 4. I thought it should be 3. Insert dog cheese crackers, so set the crackers for each serving. Okay, 16 and 90. 1 to 30. 2 to 16. 3 would be 19. Okay, cool. Okay, so it's 200 to 150. 50 bricks, y'all. 50 bricks. Oh wow, this is hard. How many minutes are in 2 days? Oh, okay, so let's divide 4, 3, 20 by 3 with 1, 3, 1, 13, 4, 12, 1, 2, 4, 12, 1, 40, 40, times 2, 0, 8, 8, 2, 8, 8 minutes. There are in frames of animation in our frame. Oh, 60. Let's see, actually, I could be wrong. They're 360 seconds in 1 hour. Per second. Oh, okay, 60. What? Am I supposed to say 30? Oh my god, I didn't calculate. This is my fault. Per second. Okay, this is pretty hard. So we could divide this guy by the seconds, right? Essentially. 1, 2, 2, 2 there, 6 with 2, 6 is 6, 0, 20, 4. Am I doing this correctly? Yeah. There are 86 frames of animation in 1 hour frame. I mean, let's first divide this thing per second. So divide this by 60 and then another 60, I guess. So if we divide this 1 hour by 60, we're gonna get per minute. Okay, let's see, 86, 400 divided by 60. So good. Or I could just straight divide it by that. But let's convert it first. We prefer that anyway. Uh, 400. 6 times, I guess. 360. 140. What? I got decimal. What the fuck? Oh my god, it's hard. Oh, let's just do 36. 86. 14, 1, 44, 2, times 4. Yeah, actually that's 4, 144. Oh my god. Oh my god. There are 128 ounces in a gallon. There are 4 quarts in a gallon. How many ounces in a quart? Oh shit, this is insane. I guess you're going like that, right? In a quart. Divided by 4. 32. Okay. It's probably because my back hurts. I'm kind of bored. Fuck, no street. 6. 6, 8, 7, 8. 140. I guess it's like one. Oh, it's just 5. The double number line shows the ratio of yards to miles. Alright, so we just have to divide 520 by 2, and you get like 2, 1, 15, 7, 14, 1, 12, 4, 0, 0. Oh my god, what's this number? This is 7, right? So 1, 7, 4, 0, 20, 37, 37, 5, 35, 8, 7. What? Oh, girl, what the fuck? Why do I keep making mistake? Oh my god. Okay, I'm gonna be much more careful now. I'm not gonna do any more stupid immediate entering. Should go back to my roots before, where I'm like doing. Can't even do basic multiplication. Fox is really mastery. 5, 8. Yo, I got $870 in 5 miles. Yo, this could be wrong. This is wrong. Here 5. Here 5. 3 and 2. Yo, this isn't 4. It's because that's 8. Fuck, I was thinking this was 3. Oh my god. Oh my god. I'm out of my mind. I'm out of my mind. 30, 5, 8, 3, 8, 8. Oh wow, this is divided by 4 in 1 hour, actually per minute. That's 60. Well, we got 0. 2, 120 with 30, 300, 6, 45. There are 946 milliliters in part. There are 2 pints in a part. Okay, so I guess this is 3, 4, 6, 2, 2. How many go in a part? How many milliliters are in a pint? What the fuck? Oh, there are 2 pints. Okay, so we're just gonna divide this. 2, 4, 6. Oh, it's gonna be like 3, 2, and 4. Oh shit, oh, this was in the video. Shit, I messed up. 5, 10, 0, 2, 4, 1, 16, 8, 16, 0, 0. So we have 5, 2, 80, 3, 0, 4, 2, 6, 18, 1, 5, 14, 4. A gallon of mole milk costs 5.12. What's the price in dollars of 8-ounce plus mole milk? Wow, this is hard. A gallon of mole milk costs of an 8-ounce glass of mole milk. A gallon, 8 ounce. There are 128 ounces in 1 gallon. So we're just gonna have to divide this thing by 5.12 by 128. So a gallon of mole milk was 1.528. So 8 ounces of that. So we're gonna divide this thing and multiply by 8. Fuck. I think I just do a shorter path to that. Whatever, let's just do it anyway. Okay, so 0, 0. I think this actually perfectly fits the M slide, doesn't it? It does. See 0.4, but let's be sure. Let's check. So 128 times 5. It's gonna be 40, 10, 12, 5, 6. Oh fuck no. Times 4 actually. Yeah, not 5. So we have 4, 2, 3, 7. Oh my god, this is insane. So for this part, let's try 4. 1, 2, 8 times 4, 32. 3, let's see, 8, 11, 5, 1, 2, yeah, it's actually 0.04, and then times 8 of that. Wait, what? There are 3 feet in a yard. Oh, okay. Like 3. 3, 9, 0, 1, 0, 14, 4, 12, 2, and 4. Forget this guy. 8, 0, 14. 4. Oh, this is insanely hard. Grant finds 6 peanuts, 4 raisins, 3 cranberries, and 5 chocolate chips in a handful pail of mix. For every 9 pieces in Ren's handful pail of mix, there are 2. Let's add this together. We have 5, 10, 15, 18. So half all of that to raisins. Now the table shows the number of insects by type. Bobby saw a picnic. The ratio of flies to all insects is 1 to 5. Wow, okay. So that's all together. This is 30. This is 40 flies. So divided by 8, 1. Oh, this is correct. For every 1 B, there are 10 insects. Okay, B, 4. It's actually correct as well. So if we have 4 over 4, the same thing in 1, 10. Of the squirrel's hidden nuts, for every 5 that get found, there are 3 that do not get found. A squirrel has 40 nuts altogether. How many of the nuts do not get found? Okay, so for that, with 40 and by 8, and then those are, wait, what? Of a squirrel's hidden nuts, for every 5 that gets found. Oh. Okay, so we have like, how many of nuts do not get found? 3 do not get found, so we have 3 for every 5 plus 8. So for that, we do 15. Kali had a total of 21 balloons at her birthday party. The ratio of blue balloons to get green balloons is shown in the table. 43. Blue balloons. Okay, so to get from 4 to 21. What? What? Total of balloons. Okay. So if we have this is 7 total. So times 3. Multiplies by 3. How many blue balloons? Not 12. Wow, we're in the quiz. Just a sec. Right, cool. I got myself a drink. Got myself a Red Bull for the first time. Crazy. Okay. Yeah, Red Bull. Also the quiz. 12 questions. I don't want to make a mistake. Okay. Oh wow, we got 64. Like 4. Like 1, 4, 2, 4. 8. Well, that makes sense. It should be 18. No, it's not 8, dude. It's 6. 4. So 16. That's for the 18. One goodie bag contains 2 pieces of candy, 3 and 3 small pieces. Let's put it back. Two to 3. 2, 3, 4, 6, 6. Candy, toys. 3 small toys, 2 candies, 3 small toys. Candy, strawberry, no, okay. Myron is cooking meat. The double number line shows that he needs 12 hours to cook 5 kilograms of meat. Based on the ratio in the double, how long does Myron need to cook 3 kilograms of meat? Okay, let's divide it by 5. Okay. So if you're gonna get cook 3, let's see if we can divide 12 by 5. It's 2.4 times 3. 7.4 hours. Mr. Shen likes for his homework assignment to have 2 addition problems for every 3 subtracted problems. Which problem was sent to Mr. Shen? 2 additions for every 3 subtractions. No. To this by 3, so 2 as well. 16 is multiplied by 8. And 2 is by 4, the 4 is by 2. This is by 5, and this is not. Joel is making a scarf. The diagram shows the ratio of knit stitches, purl stitches. Based on the ratio, how many purl stitches are there if there are 8 knit stitches in one row of scarf? 8 what? How many purl stitches are there if there are 8 stitches? Joel is making a scarf. The diagram shows the ratio of knit stitches and purl stitches. How many purl stitches are there if there are 8? 8 of these. So this is 2. If this is 2, then we total 4. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 purls, yes. Your recipe for tropical punch calls for 2 cups of pineapples. Oh, no. 2, 3, and 3, 4. We need to make matches on these. So for that to become the common denominator, we could try the denominator. So by 4, we're gonna get 12. 9, and so it's going to be 12 and 8. So there are more orange juice. Oh my gosh. No. We have more stronger pineapple taste, more pineapple. I almost pressed the shit. Pineapple taste, man. Pineapple taste. Makina earns money each time she shovels snow for her neighbors. So by 4 we have 12. And when 3, that looks like 18. 8 inches, 7, 1 to 6. So 12 works. Why am I even hesitating with this? So weird. Quincy was stuck inside during and after in brainstorm. 30 minutes reading books, 80 minutes in lunch, 12 minutes watching TV, 10 minutes drawing. So I'm going to call efforts. So this guy plus this guy is 30, 50, and 60. So it's from R. So if we divide it by 20, you get 3, right? 63, 6, 20 per minute. Actually. So we can divide everything else. Oh shit, why did I try to grab it? Not sure by 16. Oh, it's reading books rather than it's reading books. Much. So yeah, 60 and divide by 6, 10 minutes, so we have to divide by 6 as well for the other guys. And the reading book part is 20, so we're going to divide it by 6. Okay, someone's knocking, back. Grab and bake, bones, and bake, and back. Let's go start this whole shit. I don't want to make a mistake. Okay. So let's tell our 12 plus 18 is going to be 13 minutes. It's 20, 50 plus 10, 60. So it's span an R inside. And then within that R, we're looking for every 10 minutes. So if we divide it by 6, we get 10. Yes. So everything else, what would be something to be 3 if we divide by 6? 18 minutes if we divide by 3 would be 6. That would be really much. So here we're spending every 10 minutes would be much. Okay. I mean, if someone's okay. Select the ratio that everyone would do in that. Not really. This is multiplied by 9. 9 times 9 is 81. 2 times 9 is 18. And, no, not really. 2 answers. This multiplied by, oh wow, this is hard. Oh, this actually worked. This is by 6. Multiplied by 6, we got 12 times 6 by 4. Multiplied by 9. 18 by 9 times 9, 1, 4. Okay. Ah yeah, we won. Woo, that's first quiz. 27%. Oh my god, this was insanely hard. Okay, I guess I'm gonna leave here for a bit. I'm gonna just compile everything, and then after that I'm gonna continue. I'm still gonna continue today, but this will be part 15 for now. Okay. Actually, let's just check the results first for this part 15. Let's record some stuff. So, how much do we have? From 67, we got like 60. Wow, it's 1%. Okay, cool. Yo, what the fuck? The jump of the points. How did I even get that much? What the fuck? Wow. You earned Hypatia? You have learned Copernicus? Nice listener in racial application. Whoa, the jump in points is so much. It's insane. This is probably the one that gave me a lot of points. Let's see what this does. This is insane. So cool. See this badge. I guess it's a sun badge. It looks young. The freak. Pasha. This doesn't even show. Oh yeah, I think it's some much points. Just 2 minutes ago, I am 80, 125, it's 250. And this 80 is 320 points. That's good for almost close to a million. Cool. Okay, so that's it for part 15. I'm almost a million, so I guess in part 16 if we get a million points, it's gonna be insane, man. Now let's live it in the world of math. 22%, cool. Oh, my ratio. Wow. 15 parts and 22%. Okay, I'm gonna leave it here. Say goodbye. Bye.